Grignard reagents react with ketones to give tertiary alcohols. Okay, so if we have, I'll draw this in green, an R group, okay, which is a carbanion. Let's just make it a bromine here. So this is organomagnesium reagents. These react with ketones, such as this ketone, to give you, after reaction and workup and all that, a tertiary alcohol. So we have an R. I'll draw my alcohol here in yellow, and we have a green introduction of an R group. So we call that a tertiary alcohol. Okay, so we need all of these are tertiary alcohols, and we need to figure out what the heck they are and how they possibly could come about. Now, when you do synthesis, you generally like to use symmetry on your side. So when you think backwards, you basically take this oxygen and you think about kicking off the R group. And this is just a sketch. It's not a correct mechanism, and we're using retrosynthesis arrows. This is going to take you backwards to, maybe I should use the correct colors here. This is going to take you backwards to a ketone, okay? And, R minus hanging out. Now, R minus, remember, comes from the Grignard. That's the carbanion, okay? So obviously, you need to know how to name these alcohols, and you always work backwards when you do that. So first off, let's draw pentanol. Pentane is 5 carbons, okay? And I want the alcohol to be at carbon 3, and I want a methyl group to be at carbon 3. Okay, so I'm going to use symmetry on my side here. I see that I have this nice ethyl group and this nice ethyl group, so I'm going to keep that on my ketone, and so here I'm going to kick off and do retrosynthesis. Okay, that's all we need to do here. Just choose the reagents. So the thing I'm going to make is my ketone is going to be 3-pentanone, and the Grignard reagent is going to be the methyl guy. Okay. Now write out the MGBR. Your professor probably wants you to, indicate the correct form of the Grignard reagent, which is, it has the magnesium in there, okay? It could be MgCl, it could be MgI, but I just choose bromine a lot. In part B, step 1 is to draw out the molecule there. So let's start backwards. Let's draw cyclohexanol. Okay, there's cyclohexanol. Remember, when you have a cyclic alcohol, the alcohol is assumed to be a carbon 1, and then we have an ethyl group, okay, an ethyl group. So once again, we want to kind of sketch out what these can come from. So you want to take these lone pairs and just sketch the mechanism backwards. Okay, it's not completely correct and complete, but this is going to give you cyclohexanone, and the Grignard that we're going to form is ethyl magnesium bromide. So you could sketch that out if you like. Okay, and it has two carbons, so that's correct. Okay. So problem C. So remember, a phenyl is like a 6-membered ring. And what is methanol? Methanol is a methyl group, okay? All right. And then instead of hydrogens, we want phenols. So that's what triphenyl methanol would be. So let me sketch this whole thing out. It's kind of a large molecule draw. Okay, so here's my carbon. Phenyl, okay? And so again, the procedure involves taking the lone pairs on oxygen and kicking off an R group. Now, it doesn't matter which one you choose in this case, which is interesting. And again, this is just a sketch of the mechanism. What we're going to form here is a ketone with 2 phenyl groups. The name of this is called benzophenone. And we're going to form a Grignard reagent that's based off of the phenyl group. So there's 2 different ways you could indicate this. You could actually draw out the phenyl ring and bond that to the MgBr, or you could write it as phenyl magnesium bromide, like that. Okay? You don't need to write both, but I'm just teaching you that pH is a nice abbreviation for phenyl. For part B, we have a crazy looking thing. Remember, non means 9, so let's sketch out nonane. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's position the alcohol at carbon 5. And let's position a phenyl group at carbon 5. Okay? So that's a really long bond. I just don't want to bump into the labeled 3 there. So again, same procedure. Take your lone pairs right here, boom, and then you want to kick off one of your leaving groups. Now you'll see that we have 4 carbons on the left and 4 carbons on the right, so you want to keep the symmetrical ketone, and the best thing to do it would be to kick off the phenyl group. So this can come from nonanone, try to say that one time slowly, and phenyl magnesium bromide. So here I'll just use the shortcut because we've seen it before, pH MgBr. Okay, any professor would accept that. I really doubt they would want you to draw the phenyl ring. They would mark that wrong. Okay, so that's how you do this problem.